There we go. All right, so started recording, and thank you, Brady Loomer and Contessa Cooper, for being here with us as the featured speakers. And thank you all guests for joining us today. So this will be recorded and it will be used for educational purposes as well. And with that said, actually, while I make sure that everybody can share, so I've got the multiple sharing on. But also I wanted to start, I usually start by showing a short video of our 2-minute explainer video of FrontierDAO. And then also today, I'm going to take I'm going to take the stage for a few extra minutes, if you'll permit me, guests and attendees, because of the huge announcement that just happened on Monday about fusion energy breakthrough. And because this workshop has been all about fusion energy, I would be remiss if we didn't spend a couple of minutes talking about that. And also, one of our former guests from a couple of weeks ago, the CEO of Eurofusion, prepared a statement for us, which I think really explains just terrifically what just happened, even if you don't know anything about fusion. So I'm going to read that statement for us. But let's start with the FrontierDAO explainer video. That should let us all kind of settle in.
FrontierDAO is a decentralized, autonomous organization focused on scientific and engineering innovation. It is one of the first DAOs focused on scientific pursuits, hence one of the pioneers in DeSci, decentralized science. As a collective, FrontierDAO's main mission is to make scientific research, collaboration, innovation, and commercialization more accessible to wider groups of people, regardless of where they come from. Our philosophy, echoing that of NASA's, is that good ideas come from everywhere, and we are using the blockchain and Web3 tooling to help facilitate that people with good ideas, drive, and determination get access to funding, mentorship, peer support, and paths towards collaboration and commercialization, while still protecting their IP. FrontierDAO is committed to creating public goods by leveraging emerging technologies to benefit every human being on our planet. Catalyzing space and fusion technology incubation, FrontierDAO is working towards the vision of clean energy democracy. That is, clean, cheap, abundant, on-demand energy for all. By facilitating multiple pathways for funding for fusion energy innovation, FrontierDAO aims to collectively help make clean, affordable, and accessible energy available for everyone on the planet. We aim to do this by supporting paths to commercialization of this new technology, while still protecting the rights of the inventors and researchers to ultimately create a more vibrant, abundant future on this world and off-world that is shared more equally by all. FrontierDAO's work to support research as well as inclusivity in science, engineering, and the aerospace industry includes adopting space technologies to earth sciences to improve the quality of life on planet Earth as we simultaneously reach for the stars and become a multi-planetary species. Visit frontierdao.xyz today. If you have questions or would like to know more, feel free to reach out to co-founder Paige on LinkedIn.
Okay, thanks. I think some of you have seen that already. And then now I would like to share about what just happened at the National Ignition Facility. And I'd like to read Tony's statement that he sent me, just this morning when I asked him, hey, what's your take on this? So here it is, ignition. So not so many, we all have so many things going on that we can't necessarily stop the world and pay attention to everything. But this is something that, in case you missed it, the world really shifted this week, because the National Ignition Facility at the Lawrence Livermore National Laboratory in California achieved breakthrough. So it's something that they've been working towards for 60 years. It's been a global effort, and even 5 years ago, not even 10 years ago, even 5 years ago, fusion energy was still this holy grail that only science fiction people would talk about. And yet here, on Monday, they made this big announcement, and Secretary Granholm of the U.S. Department of Energy had a huge press conference earlier this week to announce the breakthrough. And why is this so? Let me read Tony's statement, because he really does a great job of explaining, even if you're like me, not a nuclear physicist, you can understand his explanation. So I'll probably have to put my reading glasses on. But so here's a statement from Tony, and maybe some of you remember him from a few sessions ago. He's the program manager and CEO of Eurofusion. In fact, Brady, he absolutely loved having your class join in on that session. So thank you so much.
Okay.
So in his words, our fellow researchers at the National Ignition Facility in California have just officially announced the results of their latest fusion experiments. In a live press conference, U.S. Secretary of Energy Jennifer Granholm and NIF researchers confirmed the first ever demonstration of a break-even result in controlled fusion energy. It gives me great pleasure, he says, to congratulate our American colleagues on this remarkable achievement. Let me scroll down a little bit. To compress, I scroll down just a little bit too much. Most of you will know that the NIF approach is very different from our own magnetic confinement approach to fusion. So our tokamaks and accelerators use a magnetic cage to capture a hot plasma and hold it for an extended period of time while pushing it towards fusion conditions. In contrast, NIF uses inertial confinement and focuses 192 high-power lasers on a fuel pellet the size of a peppercorn, right? So just tiny. By bouncing these lasers off the insides of a tiny gold capsule around the fuel pellet, it's called a holram, they create a bath of X-rays that compresses the fuel pellet to roughly 1,000 times the density of water and more than 100 million degrees Celsius. In the millionth of a second, the pellet reaches fusion conditions. And if you go on YouTube, you'll hear the researchers talking about it. It's a really great press conference, even if you're not a nuclear physicist. On December 5th, at a little past 1 a.m., the NIF team sent 2.05 megajoules of laser energy into their reaction chamber and managed to compress their fuel pellet so smoothly and uniformly that the fusion process could release 3.15, right? So more energy out than energy in. And that's what breakthrough is. That's what break even is. Megajoules of energy. That comes down to a gain factor called Q of about 1.5, a world-class achievement. NIF has been reaching for these conditions over the past several years. In experiments in August, they had reached an output energy of 1.35 megajoules, about 70% of the injected energy, a marked improvement. Oops. Again, scroll down a little bit too much. In 1 year's time, we've seen the announcement of two remarkable achievements in fusion energy. NIF creating the very first fusion ignition comes almost exactly 12 months after the record shot that released 59 megajoules of fusion energy. When future historians track the development of fusion energy, I believe, says Tony, they will identify this year as one full of historic milestones. Both results give us further confirmation of the science and potential of fusion energy. I'm sure this new result will fire the imagination and motivation of the global fusion community as we continue our work to realize fusion energy. So, and of course, fusion energy means clean, abundant, cheap energy for the entire planet. And both Brady and our featured speaker Brady Loomer and Contessa Cooper are both going to talk about this subject, but from very different angles. And I can't wait to see this. So, without further delay, I'd like to introduce first Brady, who is the space program director at St. Mark's Preparatory School in Boston. And I believe he has a presentation for us. And after Brady's, we will seg to Contessa Cooper, Contessa Louise, who is our subject steward for the day. So tell me what you need from me, Brady.
I can share my screen. I have my presentation up, but I can also probably, since everybody can see me, I'll introduce myself first, just so that you're not looking at a presentation without seeing me. All right, so hello everybody. So happy to be here. I think this is a perfect example of why I get so excited about space, is because I firmly believe it can be so deeply entrenched in everything we think about and talk about in our daily lives. And while it may not necessarily be a distinctly direct connection, it can always be applied in some shape or form. And so my background is I have a bachelor's degree in chemical engineering, but I switched briefly after being in industry to being a secondary school educator. And I've been a science teacher at St. Mark's outside of Boston for the last 12 years. While I technically teach a lot of chemistry, for the last 7 years, I have really become extremely passionate about space and space education. And so that's where I developed the St. Mark's Space Program to try and educate not just my classes, so the courses that I've developed and the students in its programs, but it's really meant to educate my whole school community. So both faculty, their families, parents, alumni, and trying to get them just in touch with, like I said, the passion to discovery, but also the realistic connection that space offers to all of our lives. And in fact, just this morning, I had a wonderful conversation at breakfast with a faculty member who's an Orthodox Greek, and he was talking about the origin and language of what planet means. And it was fascinating. And it was just like such a wonderful conversation about how like it is ingrained even just in the origin of language. And how we live our lives. So I've been doing that for about 7 years now. And like I said, I take as many opportunities as I can. So thank you, Paige and FrontierDAO, for, kind of giving me a forum to keep on spreading the great word of what space can bring to our lives and how it can make a distinct difference in something as important as energy justice. So. All right, let's get into it. Now, Contessa probably has a bit more of a background than me in kind of talking about some of these subjects, but I very much love, like I said, the interwovenness of just, I think, any topic in general, and the fascinating part that as you dive into energy justice, it just has everything as a part of it, like social justice and talking about, social systems and race and demographics, and not just domestically in the United States, but internationally. And it is so expansive. And that's just from like a philosophical standpoint, is just like exactly what space is. So I think these are so wonderfully commingled together. But just from kind of the surface standpoint, like energy justice, and like I said, isn't like it's such an expansive thing. You might hear it as energy democracy, a lot of other terms, but this is something that is being noticed by those in government, United States and other, of a piece of importance. And the data has fully supported the fact that communities of color and low-income communities and marginalized communities have borne the negative outcomes and reaped less of the positive outcomes of energy production and environmental conditions related to energy since it's kind of began. And so it's where you kind of look at what is justice and how does it look. And so energy justice, like I said, lives kind of at the center of three areas of justice that just make it so complete. So if we think about, what I was just saying of restorative justice, harm has been done. So how do we fix that? We can't make progress until we, one, acknowledge the past, and two, begin to repair some of those things. Shifting the burden off of some areas and ensuring that harm doesn't keep on continuing. Procedural justice, getting those individuals involved in the conversation, because again, unless they're a part of the conversation, you don't know what is happening on the ground with the communities that live there. And so what does restorative justice look to them? And then lastly, distributive justice, connecting to the repairing is how is the weight, because again, part of, the energy infrastructure systems, environmental conditions, etc., that has always a benefit, but also a burden. And so neither of those can fall on one group. You have to equally distribute between that. And this just highlights, I like this graphic just because it highlights so many pieces of energy justice and how there's a part of economics and policy and representation, how we use energy, how we produce energy, what does it mean about access to energy? And then, as I'll kind of bring up a lot in the next few pages, is really the distinct connection to poverty as well. And of course, the extension off of that is it is usually marginalized communities within the United States that also have significantly higher rates of poverty. So those are not separate, but poverty is a bit like more of the more expansive connection between things, along with others as well. So a bit of just geographical data to kind of, again, just draw the connections between groups is that throughout the United States, this happens in many different areas, but the consistency that you can see, and what this is representing is communities that are essentially below the energy poverty line. And what the energy poverty line is, for every $16 of income, $1 goes to energy expenditure. And so that comes out to be, I think, just over like 6% of your income. And so if you're spending greater than 6% of your income on energy, lighting your house, heating your house, those where you're living, etc., that puts you below that poverty line. And so the consistencies within this, and I don't have the technical expertise to overlay another image on top of it. I suppose I could have paired them together, but areas of red and orange, you'll typically find, one, particularly in the north, those are very rural communities. So economic opportunity and access to economic opportunity in those areas is very difficult to come by. You'll also see out west that overlays very highly with Native American reservations, and indigenous groups have typically borne the brunt of a lot of environmental consequences of the energy industry. And then the deep south, so along the United States-Mexican border, which is where there's a high group of immigration related, which then also carries some economic and poverty consequences. And then, of course, large areas of Black communities and urban communities that are involved with that. So you see high areas of red, orange, or yellow in Mississippi, Louisiana, Alabama, Texas, etc. And so extending off of that, diving a bit deeper into our more specifics, we do see very distinctly, if your income is above the federal poverty line, you are highly less likely, and I can't accentuate highly enough, to have an energy burden. And that, I think out of any of them just shows the distinct connection between those. As you then, extend to things like race, Native American, Hispanic, and Black, these last three lines there are 10-20% higher than white and Asian groups. Education plays a big role. And of course, we know education plays a large role in income and career and access to job opportunities that may not pay as much as others. And of course, there's so many others. And, if you were to, again, connect back to the geographical where people live has a distinct connection to economic opportunity. And this all just kind of plays out together. And then lastly, this is not a surprise to individuals that live in these circumstances. And so this is a self-reporting to Pew that lower income Americans see this stuff in terms of waste and landfills, visible and known contamination of lakes and streams, knowing the outcomes and feeling the outcomes of air pollution, access to safe drinking water, and then just the physical representation of green space and parks. And so, ideally, these numbers would probably never be zero for any community. However, if you even just compare the white respondents to any of the other groups, it's significantly less. And I think that's at the very least a distinct beginning point to examine what are happening in those communities that isn't happening in others. And of course, as we think about all those problems that can arise in energy justice, they're kind of highlighting the other problems that exist within all of our societies. Inequalities, any negative outcomes for health, particulates in the air, drinking water, etc. Poor environmental sustainability, and how you're drawing resources and the excessive draw of raw resources from the planet, again, typically happening in certain areas. And then, of course, the low economic opportunity that I brought up in the past. So how do we fix it? I believe, again, if you didn't hear me at the start, that space holds some answers. Is it the answer? No. But I think it holds some pretty distinctive answers and is a it is a great way to combine and pursue the outcomes that we want for both. And so, when we think about how we provide solutions for any problem on Earth, acknowledging reality, for instance, the energy industry, you are talking about established corporations that exist within a profit-making structure. That is what capitalism is. And so this isn't to say that capitalism is good or bad. However, until they're incentivized, usually economically, to make changes, change will be slow to come by. And so what you ultimately need is solutions that are disruptive and competitive. And when you get disruptive and you get competitive, that usually gives someone, even the most resistant, a nice little kick in the pants to be like, okay, how can we adjust? I guarantee, and I talk about this a little bit right at the end, Paige, fusion will be that. And space technologies provide that on a regular basis already. And so if we start to really think about how you actually can pursue some better energy justice, both in America and the world, you can do that while also participating, having companies and technologies being a part of our normal economic development. And so just a quick picture of what space in the space industry means. You know, we always think of Apollo, and, you know, that's kind of the big standpoint in our head of where, you know, space exploration kind of began. But if you really think about space as an industry, it's really kicked off quickly within my lifetime, certainly, around where it existed with a few groups and companies within the early 2000s, and even within 15 years has just grown. It's doubled, over doubled, 176% if we were to look down here. Within 10 years, 50% growth. And so what's fascinating is it's actually being not quite spoken about in terms of a industry anymore. It's actually being referred to as an economy. Like, it will be an economy in and of itself. And it's also kind of highlighted by the fact of the diverse amount of countries that are now launching their own things. And so when we think of economics, a lot of times, yes, we talk about global economy, but we also think about economics divided by borders. But of course, does space have borders? No. And so it's going to call for a completely different economy that involves international companies and groups, so public and private, working together without borders in order to make this work to the benefit of everybody. And right there, I think you have a great metaphor for how energy justice should work. So, just if our space economy is booming, that means we're developing new technologies. And anytime you're developing a new technology for space and kind of thinking through that startup and that entrepreneurial spirit that's kind of kicking in on a regular basis, you're developing all sorts of things. The ones I'm going to talk a little bit about here are energy structures and some environmental technologies. But of course, I mean, satellites are a huge piece of that economy right now, and communications. You can talk about, you know, the how imaging from satellites can have an impact on energy justice. There's so many, don't have enough time for it. So I picked out some really cool ones. So what is great in the United States is that since NASA is a government group, I mean, really just a whole branch of government, its purpose is to feed back into the US economy. And so the number changes year to year, but in the early era of Apollo, for every dollar that was being put into NASA's budget, around $7 were returning to the US economy. And that is about supporting jobs through NASA and NASA affiliated companies, to technologies that are feeding back into creating, say, new companies. There's a whole variety of ways. At its peak, and I forget what year this was, it was about, for every dollar in NASA's budget, it was actually $40 that was coming out. And right now, I believe we're something between $12 and $15 for every dollar in NASA's budget, which I gotta say is a pretty excellent return on investment. And just if we look at the role that NASA has played in its tech transfer program, which is really technologies and research that have happened at NASA, how that spins off into the creation of companies, or just the spread of the technology that was done in the research. And that is typically done through partnerships and programs that get both existing or new companies formed and involved in the work that NASA is doing. And so I think just what serves as one of pretty much, like, I think of as one of the most successful of the tech transfers, and has a piece involved in energy justice is just the idea of farming and how we produce food. Okay, and so of course you want to produce food in space. You know, if we're going to put people on the moon, if we're going to put people on Mars, if we're just going to exist in orbital stations, you can't constantly ship food back and forth. Like that becomes highly expensive, resource intensive, and it's not a very sustainable approach. So you're going to have to grow your own food there. Space provides a whole bunch of difficulties around how does water act? How does a plant grow in zero gravity? How do you get nutrients and fertilizer to the plant? And so there's a number of companies, one in particular, and I'm forgetting its name now. They're based out of Florida, and it was basically a water-free fertilizer that you could just apply to the roots of the plant that was not impacted by a microgravity environment. And I think the yield was 20 to 50% greater in terms of the plant size when they didn't. And of course, if you think about the fact that you're trying to grow things with less water, well, how many places on Earth are having a problem with clean, fresh water? How many places on Earth are just dealing with drought currently? How many places just have such extreme environments that growing crops outside is incredibly difficult? And so when you look at just the fact that we haven't applied this really globally yet, but even just to a number of companies, the growth between 2021 and 2026, I'd say that's pretty impressive growth for a 5-year period. And if you can extrapolate that from solving a problem on Earth and what other technologies can yield, I think we have a pretty strong argument. So a few environmental spinoffs, and this literally is called the NASA spinoff program. A few things that I think are a piece of energy justice. These a little bit more environmental justice is a part of that. In the news were, the biggest concern, one of those forever chemicals, PCBs. And so actually, Paige, as you brought up the phrase, good ideas come from everywhere. The cool thing about this one, so ecospheres, is that it happened at the lunch table in the cafeteria at Kennedy. And so a NASA engineer was looking at her straw, and it just like popped into her head about how this could be used for solving this problem of PCBs and water supplies. And so from this idea of this straw, and she actually did the first experiments with a plastic straw, it's being used to capture and remove PCBs from various different water sources. Again, marginalized communities have a higher rate of contaminated water, probably by things like PCBs, and up to a 30% savings on the traditional methods. A fairly simple tool to remove something that is really difficult to remove. Of course, there's another thing in the United States, and again, I don't know internationally what this is, but Superfund sites. Superfund sites are related to contaminated industrial sites throughout the United States, with a whole host of contaminants from industrial processes, but one of the worst is chlorinated chemicals. And so these also have a tendency to hang out for a long period of time, living both within the groundwater and in the soil. And so either or, if you're talking about living on the land or drinking from the land, you don't want this around. And so emulsified zero valent iron, essentially what it does is it breaks down the chlorine, the chlorinated compounds within the groundwater and the soil. And this is such an excellent application. And it was just in terms of context, it was developed because of contamination around one of the NASA sites. I think it was particularly related to rocket fuel. And so the application takes days, and immediately they're seeing positive results in months, and up to 90% of the chlorine compounds have been broken down in the application area within 6 years. Traditional applications took over a decade to begin to really kind of see some positive results from the application. And so you're talking about something that is fairly easily applied. It has no real negative outcomes in terms of after its application. And you're yielding some strong results also cheaply. This is also just a super cool one. And it's also a super cool one because it could be applied to talking about energy production. And so I borrowed it from the page because I just didn't want to change really its language because it's so cool. And so really what it is it's microbes that will break down waste in order to generate electricity. And so what they do is they break down the waste, then create methane. And then you can use that methane to burn as a natural gas for your power source. Now, is that a fully green energy source? That would be a whole other debate. Methane's better than most things, but it's still producing carbon dioxide. But the fact of the matter is that just 2 of these reactors are producing 95 kilowatts of power, which isn't little. It's not massive, but it's not little. And it's eliminating 4,000 metric tons of carbon dioxide, which is a pretty big win, at least in my opinion, for some microbes. And it's like that fascinating aspect of how biological life can connect to chemistry, can connect to energy, can connect to technology and environmental justice. So energy spinoffs, and this is both connected to energy creation and also energy efficiency. And so aerogel, you may or may not have heard of aerogel in many different aspects, but it was developed mainly as for applications in space due to its incredibly lightweight and also its incredibly impressive insulative properties. And so it really performs at such a better level than anything that we have existing, plus its cost of development, while it is on the high side, is going down significantly. And this is just a perfect example of where, yes, this was designed for spacecraft and then industrial processes like pipes in factories, etc. But why not apply it to, say, a large scale apartment complex that's using steam heat? Because you're not going to tear down the whole system. You're not going to tear down the building just because, say, the steam system isn't efficient. But you know what? Anything you can do to make that steam system more efficient is going to be better for the occupants, is going to be better in terms of how much energy you use to produce that steam and get it to its residents. And you just begin to quickly see how that can improve the lives of people that, you know, otherwise might not have a choice other than living in an apartment complex. So, you know, the task of sustainability goes down. Another one, giant batteries. And so it's a really simple battery. It uses only iron, salt, and water. And so it has no toxic byproducts. And so the point of it, and this is kind of the grail of energy in general, is when you have renewable green energies, particularly things like solar and wind, what do you do when the wind doesn't blow or it gets cloudy and the efficiency of your solar cells goes down? Well, you want to hold on to the power that you've generated when there is highly windy conditions or highly sunny conditions. And, you know, it is a continual research and development right now that's trying to work on this being one of them that doesn't involve a lot of the heavy metals that we see in our current generation and battery technology. And so these batteries can store up to 12 hours of energy, discharge it completely, and not see a drop in its efficiency when they get recharged again. And so when you talk about rural communities, areas that can take advantage of renewable energies, but of course, the access to it, if say the weather conditions don't cooperate, you need something like this to be working in partnership. And, a good battery, which this is, provides that solution. Now going to the tad more extreme, if we are talking about living on a lunar base, it is a pretty much, if you can solve a problem for a lunar base, you can solve a problem for anywhere on Earth. There is not going to be anywhere on Earth that is worse than a lunar base. So what are some solutions? Well, currently the solution that they're kind of aiming for is fission. And mainly it's because that is the technology related to nuclear that we've known the longest. Fusion has had a long time of development, and fusion has existed in use for a period of time.
Oh,
yes, Paige.
Sorry, Brady. I think you
did I just flip it?
Fusion and fission. Yeah.
Oh, sorry. Fission has been in use for a long period of time. Fusion has been researched for a period of time. Thank you. However, doesn't have commercial uses now. So fission is the technology we know. And so can that be, downsized to be not the massive nuclear power plants that are producing, millions of kilowatts of power for large amounts of people? Can we downsize that to a smaller generator for a smaller population of people? And what the advantage that comes with fission is that really it doesn't matter about your environmental conditions, it will work. And so you're not dependent upon the shifting conditions that happen on the moon or say Mars. And if you think about it too, a lot of the negatives that come with fission and a lot of the negatives that we at least think traditionally of fission don't become as much of a problem on, say, the moon when you're talking about a lack of atmosphere or just in terms of temperature and how some of those accidents can really grow in larger scale proportion. My class is currently watching Chernobyl, actually, as an example of a dramatization of an accident. But yes, this did actually happen, and what can we learn from it? And so this is in development. There's 3 separate companies. So like Boeing is working with a couple of smaller companies to really figure out the best system to use. And ultimately, they want it to be a 40 kilowatt system to essentially power a small moon base. And I think that's part of, again, if we think about the energy justice movement and how we can provide good energy to people. I'm a proponent of nuclear, either fission or fusion. But one of course, the aspects of fission that's such a problem is when you scale up something, it does get incredibly expensive and incredibly expensive to upkeep and to continue running for the life of it. And so if you can build smaller reactors, and there has been a number of research that's been done on safer fuels. So I think at one point it was lithium salts, and there's a few others where they're using the model of fission, but maybe not with something that is so radioactive and difficult to treat and dispose of once its efficiency is dropped to a certain level. But smaller reactors that can be spread out and provide power to a smaller limit of customers, so that disruption, issues with turnover and life of the facility doesn't become such a problem. But of course, since this is space, there's plenty of opportunity for things to, kind of out of that box thinking. And so I'm just going to skip to 3 for one moment, because it's the most obscure out of all of them, because it's a great idea. You're on the moon. Of course, you're getting a decent amount of sunlight, and now you don't have an atmosphere. So there's less interference. There's no clouds to get in the way of your solar cell generation. So it's a great idea. But of course, when you're living on the moon, and the way that the moon collects sunlight is that really you got sunlight for 2 weeks, and then you got darkness for 2 weeks. And so, well, solar might be great. How do you avoid that? And so their idea was literally build a whole ring around the equator of the moon in order to provide 24-hour coverage. Downside is it's a full entire ring around the whole moon. Is that feasible? And getting all those materials up there? Good question. It's possible, but that's taken up a lot of space and would probably be a rather expensive prospect. Some things, and this is, I think, also a piece of the space technologies that is just wonderful. Is this was a college student, Aaron Bonanno, and from New Zealand. And so in 2012, he wrote a paper on it, and then afterwards did produce this idea. The paper was for like a college student competition. And then he actually put it into action, which is basically using lunar regolith to create bricks. And what he was able to demonstrate is that they actually work as a great solar thermal energy storage. So heated up, the bricks are able to hold on to that heat. And then what can you do with it? Of course, as a building structure, if it can hold on to that heat, those 2 weeks, sorry, drying out. Those 2 weeks become less of a problem if your structure is able to hold on to that thermal energy for a longer period of time. You know, and then he even had proposed, and I forget exactly what it was, but a literal electrical generator that draws off of the thermal energy stored in the bricks in order to generate electrical power as well. Lastly, another one that connects to kind of the combination of the two, where yes, you can use solar cells on the moon. It's a great idea. It's just where can you put those solar cells in order to collect as much sunlight as you can? And so the idea is basically to create towers of regolith, so still using your Martian or lunar soil for building structures, and putting them at these points of peaks of eternal light. So it's basically at the points in lunar craters, a little bit further out from them. There's these spots that if you get high enough, you actually won't miss out on sunlight. And so if you can strategically place these towers, you can actually still have sunlight shining on your photovoltaic cells without covering the entire equator in solar cells. And then, of course, as Paige brought up at the beginning of this, ideally would obviously want to get to a point where you could use fusion energy, because that is so self-sustaining and long-serving that would be our best option. Of course, we still have to make that commercially viable. So right now we've proven it from the science perspective. It's now the engineer's job to figure out the systems that can turn this into something that we can use as a larger scale energy source. And as it stands now, you know, I think one of the biggest questions in engineering that always exists is it's actually easier to build on a larger scale, and getting something to work at a smaller scale can sometimes be very difficult. And so fusion and getting it within a very small confined thing, because getting stuff up to the moon or to Mars, if it's heavy, it's not going. It is, you know, I think something that generations or decades down the line could be a possibility. We just got to make it work here first, which is why they're thinking fission before fusion.
That's awesome. That's awesome, Brady. Sorry, just doing a quick little time check.
Oh, geez.
Want to give, yeah, no, it's so enthusiastic.
Sorry.
I'm riveted. Yeah, it's wonderful. But we do want to give Contessa her
Of
time.
course.
Yeah.
So anyhow, thanks so much. I hope this leaves you at a good place. Contessa, I apologize.
No worries, no worries at all. I was just really into what it is that you were saying. Some of the things that I'm going to get into kind of overlaps some of the things that you said in the beginning, but I want to be here to kind of give a general overview of what energy justice is.
And
Thank you,
let
Paige.
me, yeah, let me quick
Sure.
introduce you.
Oh, thank you.
Yeah, no, so Contessa's wonderful. She's quite a steward of Web3, and she has onboarded a ton of people into Web3. So she, she's a mastermind at that. And now she's also started to apply her acumen to the subjects of energy justice. And something she said to me recently too, which I think relates very well to what some of the subjects that Brady was saying, is how, and I'll let you, please, jump off on this, because she said to me recently, she said, food justice and energy justice are related. So it's fabulous, Brady, that you touched on those topics, because that's exactly where Contessa and our minds were. So without further, Contessa, please, it's your stage.
Thank you. Can you see my screen?
Yes.
Awesome, awesome, awesome. So again, thank you so much for allowing me to show up and talk a little bit about energy justice. My background, really, I'm new to this climate space, to this energy justice space, to this regenerative space. And just to let everybody know, it's not too late to get started. I'm a 50-year-old Black woman, and if I can do it and get involved in this fight, you can too. I do have my notes here so I can sound a little bit smarter than I actually am. So let's go ahead and get started. I want to get started by saying ultimately, energy justice strives to create a more fair and equitable energy landscape for all. So, what is energy justice? It is a concept that seeks to address the systemic, unequal distribution of energy related resources and benefits for society. The goal is to ensure that everyone has equitable access to clean, renewable sources of energy and the economic benefits generated by those sources. This includes addressing disparities in energy costs, access to services such as lighting, heating, cooling, and environmental impacts. Why do we care? Why is this important? Energy justice is important because unequal access to energy creates disparities in quality of life, health, economic opportunities, and education. People living in impoverished areas are often forced to rely on fossil fuels that create pollution and can be hazardous to their health, while people living in more affluent areas can access cleaner, renewable sources of energy. Energy justice seeks to bridge this divide by advocating for a fair and equitable distribution of energy-related benefits across society. What are some of the challenges? One of the challenges is finding ways to make clean, renewable sources of energy affordable and accessible for people at all income levels. Another challenge is getting government support for initiatives that increase access to clean energy and reduces reliance on fossil fuels. Finally, since energy policies tend to be a matter of national jurisdiction, there can be significant difficulties in trying to implement energy justice initiatives at the international level. Some examples include community-owned solar power projects, tongue twister there, green job training programs, and energy efficient upgrades for low-income households. Additionally, governments can implement policies that incentivize the adoption of clean energy sources, provide assistance to help people access these sources, and fund research and development in renewable energy technologies. There are also nonprofit, for-profit, and DAOs, decentralized autonomous organizations, working to advance energy justice initiatives around the world. Some benefits. are reducing poverty levels, improving public health outcomes, creating economic opportunities, decreasing resource consumption and reducing harmful emissions, and creating a more fair distribution of benefits from clean energy sources. Where are some organizations, or who are the organizations that are involved? And this is just to name a few. We have the Earth Guardians, the Initiative for Energy Justice, UNICEF, of course, FrontierDAO, Yale Climate Connections, Climate Realty Project, the Solution Project, We Act for Environmental Justice, the Indigenous Environment Network, Earthworks, and earthjustice.org. How can you learn more? And how can you get involved? You can start by reading the fictional book, 2 Degrees, by Alan Grant. It's aimed for kids, but I don't know about you, but I am a kid at heart where it counts. You can download and work through the IEJ workbook at the Initiative for Energy Justice website. You can also start right here in your backyard in your community. You can support clean energy and help make it happen. You can invest in energy sources that are environmentally friendly. And you can learn about how fusion energy can be an unlimited clean energy source that will provide a continuous supply of power. And I wanted to leave all of you with my own personal quote. If you want Black and Brown people to care about energy and climate justice, you need to show that you care about us as humans first. Thank you so much, Paige.
Contessa, that was fabulous, and I'm so glad that you left us with that quote, because I think in the last couple minutes that we have here, that would be a great, conversation, conversation starter, because both of you, both you and Brady really nailed it when it comes to this conversation about energy justice. Do you guys have any questions for one another? Because that could be very interesting.
So I do have a question. When we talk about space and energy justice, when it comes to space, it seems so abstract. How can we talk about it so that we can get more people in my community talking about this and getting involved?
I mean, I think that's a great question. The part of, how I approach it as an educator is just kind of trying to see where space plays a part in our lives. And that's even then sometimes more abstract. And so oftentimes I'll just try to be like, look up, just look up. When the sun is out, when you see the moon, when the stars are out, look up. And again, from that a little bit more philosophical and abstract perspective, when you think of how humans went through time, the only thing that's been constant since the evolution of human beings has been the sky. No matter where we are on Earth, we are all looking at the same moon. And so those are to me the two things that kind of universally connect all human beings, no matter skin color, creed, religion, whatever it is. And so how that, yes, from that philosophical standpoint is a tad high, those things then can be at least the start of the conversation for how those things can work into the direct relationship on the ground, and how, everybody, the connection to, information through the internet is such an important piece of, really lifting people from areas of poverty throughout the world. Like, information access is like a huge starting point. Well, the space can get you internet access from any point on the world. Like, talk about a game changer for so many people. And It's not easy, that's for sure. But I honestly think curiosity and fascination, like even like just that's always the beginning point for so many people. It's just like, wow, that's so cool. And that's the start.
Cool. How about you, Brady? Do you got, just in our final minute, do you have I mean, I want to respect your guys' time. I can stay for however long. Do you have a question for Contessa? Maybe are your students interested in Web3, or how blockchain can be leveraged for climate solutions or space technology? Or
I mean, from the opposite side, Contessa, like, as you said, like your question can be in a way flipped of like, how can I, because it is a distinct point among students of like, why are we spending money on, going to space when people are starving? I always kind of flip it on its head and being like, why are we spending blank times more on our military versus space exploration? And they go, oh yeah. But it's still kind of evolved into the same thing of like, what can people like, what is it like, what is a great connecting point to start with in terms of beginning that conversation, particularly with people that come from places that they're more concerned about just food on the table and keeping the lights on, and seeing past that it's not a part of their life because it's hard.
It is difficult. And that's kind of one of the questions that we always ask is, how do we onboard people into Web3? How do we go beyond people who really don't even have their own basic needs met? And the answer I always give is, we meet them where they are. That's why when I start talking about climate change and food justice, we start with food. While we are feeding people, we start talking about these other things. And that's our connection. While we're housing people, we're talking about this. While we're making sure that people have clothes and they have access to childcare and ways to get to work, and they're paid, a living wage, then we can start talking about these other things. But first, we need to connect with what it is that they need on a basic level. We need to tell people that we care about who you are and what you need. And then and only then can we talk about bigger and greater things that are out there. But we got to start with needs first.
100%.
yeah, I love that. I love that. That really brings home where the conversation needs to start. You guys are both of you are so brilliant, and you bring such, gravitas, as I've said before, to this conversation. I really hate to end this, but I have to respect people's time. I do have the recording. It'll take me well, this will probably be off the recording but I'll get it to you guys in a few weeks. But this has really been so brilliant. I want to thank you both very much for agreeing to come and speak so knowledgeably and from the heart. And I also want to thank all the attendees. There's been a lively chat with all kinds of great information going back and forth. Any final thought, or what are your final thoughts? Let's start with Contessa, and then we'll end with Brady.
Like I said, I don't know where you're from or what your interests are, but it is never too late to get started in this fight. Starting with energy justice, with climate justice, with just being kind to your next door neighbor is how we get started in this fight and let people know that we care about each other.
I would 100% second that and add on that, I think with space and entrepreneurship, like if you are interested in space and space technologies and developing them for any part of the world, keep all of these things in mind, because you can develop a successful business, a profitable business, and have a great business model, and yet still have something that can support and ultimately make a difference in so many people's lives. And if you can do all of that all in one, like, man, sign me up to invest. Though I'm a teacher, so I don't have that much to invest. So don't count me as the investor.
Thank you both so very, very much. Have a great rest of your day, and wishing everyone very happy end of the year holidays to you all too. Okay.
Thank you so much, Paige and Contessa, and everybody else.
Thank you, friends.